We're going to look at another question. It's titled Maximum Manhattan Distance After K Changes. So it's question number 3443. Now let's look at how we're going to solve this question. So the first description of the question is that we have given a string. This string consists the character of n, s, w, and e. So the character n represents north, where we can move one unit up in the Cartesian coordinate, while s represents south, where we move one unit down. E represents east, where we move one unit to the right, and w represents west, where we move one unit to the left. So we also given a value variable k with the, for example, value 3. So what does this k represent? The k represent the amount of time that you can change a character in the string of s to a value that you want. For example, we can change the value of n to the value of s, e, or w. So the aim of this question is to find Manhattan distance. So what is the Manhattan distance? So Manhattan distance is actually a distance between 2 points. For example, you have point 1 with the x coordinate of x0 and y coordinate of y0, and you have another point with the x coordinate of x1 and y coordinate of y1. So the Manhattan distance is basically your counting the difference between the x value and also the y value between these 2 points. For our case, since the origin point is actually 0, you can actually simplify the problem. So if you substitute 0 here, right, you will see that the Manhattan distance is actually simplified to xy and y1, which is the current position in the Cartesian graph. So you just take the absolute value of xy and y1 and you add them together. That is your Manhattan distance. This is simplified because we are starting the origin from 0, 0. So let me show you. Okay, for example, if we were to move in north, then if you move to the east, north, east, right, the current point is actually 2 and 2, right? So what is the Manhattan distance? The Manhattan distance is basically 2 plus 2, which is 4, right? So if we move to the south, to the west, south to the west, the new coordinate will be -2 and -2. So what will be the Manhattan distance for this coordinate? It also will be 4, because we are taking the absolute magnitude of 2 and also the absolute magnitude of 2 and we are adding them together. So in this case, we are trying to find the maximum Manhattan distance. We are actually trying to go the furthest away from the original point. For the first example, where we move to the north, to the east, north to the east, right? If we continue to moving north and east, we always continue to move away from the origin point by 1 unit. However, if we decided to move, let's say after move 4, we decided to move south, right, and then we move to the west, what will happen? Now the point is actually 1, 1, right? Yeah, the current point is 1, 1. The Manhattan distance is actually 2 only. So by moving to the opposite direction of north, which is south, and also the opposite direction of east, which is west, we're actually moving backwards, and we're actually reducing our Manhattan distance. So what we can conclude is that in the event that we are moving north and east, right, we have to avoid as much as possible the movement of south and west. If we do that, we actually increasing Manhattan distance whenever we're moving north to east, right? So let's look at the other example. The other example here is that we are moving south, and then we are also moving in the direction of the west, right? If we keep moving south, you can see that the new Manhattan distance for the point -2 and negative 2 and negative 3 will be 5, right? So the correct coordinate is this, right? So the Manhattan distance will be 5, right? However, if we decided to move to the north, right, we actually coming back to the same position, which is actually negative 2 and negative 2. And if you move to the east, we actually at negative 1 and negative 2. In this case, the Manhattan distance become 3. So in this case, when we are moving south and west, we have to, as much as possible, avoid the movement of north and also the movement of east. If we do that and we keep moving south and west, we're going to get the maximum distance from the origin. So what about this case when we are moving north and also west? In this case, we have to avoid the movement of north and east, south and east, sorry. If we keep moving north and west, yeah, we'll be moving away from the origin, right? Similar to here, where we're moving south and east, we have to avoid the movement of north and west. If we do so, we will keep moving away from our origin, right? The new point will always be further than origin. So this is the 4 position that we have to consider. We're trying to find these 4 optimum position, either in the southeast, northeast, southwest, or southeast, by changing the character in the string, so that in each instance, in each direction, 4 separate direction, we are avoiding the opposite direction, so that the maximum Manhattan distance can be achieved. So another thing about this question is that it asks us to find the Manhattan distance regardless the length of the string, right? So if you are given the string with a length of 6, right, you're not going to wait until the length of the 6 and only find the maximum length, maximum Manhattan distance. It can happen even the length of 4 or length of 3, right? So you always have to keep track of the biggest or the best Manhattan distance at each point of the string, right? So moving on, how we're going to solve this problem. So the main idea is that we have to consider these 4 different direction, which is the northeast, northwest, southeast, and also southwest. And we also have to minimize the opposite direction. When in the case of northeast, we have to actually minimize the operation of the southwest. And we can do that actually by minusing the value of the minimum value of k over sw. So there's a limitation here. For example, if the k value is 3, right, but then you have the value of sw, which is like 7, the maximum changes that you can occur is actually 3, which is limited by the value of k. You also can have the situation where you can have 0 SW, right? And although the value of k can be 3, but since there's no S and W that you can change, what happens is that you actually can only have 0, right? So you can't change anything, so this will be 0, right? And then at the same time also the value that you have changed, right, you also is actually providing you extra movement in the positive direction that you want. So that's value you have to add, and this is also limited by the value of k and also the value of the opposite direction that you have in your dictionary. Now let's try to solve this question by one by. So let's say now, right, I will start with the first letter, which is n. So I'm going to have a dictionary here, and this dictionary will track the number of n, s, e, and value, right, in the string. So in this case, what we have is that the first alphabet is n, so we're going to have a 1 here, right? So now let's move on. Then in this case, what you have here, in this case, in option 1, when you move northeast, we are going to have 1n and 0e. In this case, we have 1 here, minus SW is 0, so minimum of k is between k and SW will be 0, since the value of k is 3, but the value of SW is actually 0, right? So it will be 0 here, and then plus 0, because similarly k is 3, but then SW is 0, so you take the minimum. So in this case, the value, option 1, the value is 1 for the index of 1 for the string s. Now let's look at the option where we move northwest. If you move northwest, you have the value of n, and then w is 0. In this case, it will be 1, right? Minus se. Se is actually 0 minus 0. Similarly, right? And plus the value of 0, since SE also is 0. So in this case, if we move by option 2, we're going to have the value of 1. Now let's look at the another option, which is if you move the southeast. So if you move southeast, you look at here is actually 0 minus, what is the NW here? NW is here, N is 1, W is 0. In this case, NW is 1. Minus, what's the value of k? K is now is still 3, but then now the value of NW is 1. So 1 minus 1 will be 0. But then the minimum value between k and NW, which is now the direction that you have changed, right? From NW to SE is actually 1. So what will happen is that the option 3 will be 1. SW is similarly, you look at this, S is 0, W is 0, so it will be 0. Minus N is what? N is 1 and E is 0. So 1 minus K is 3 and E is 1, so it minimum will be 1 plus 1. Right? Now the value is actually 1 here, right? So in the first example, what we got is that the best value that you can achieve here is 1, right? Now let's move on. Alright, in the second case where you have to add the value of s inside the dictionary. So the best value for first index is 1. Now we're going to add the value of s inside here. So what we're going to have here is that you're going to have 1n and 1s. So now let's do the equation again. NE is actually 1 minus SW is actually 1 minus minimum k and 1 is 1, and then you're going to plus 1. So the option 1 for index 1 in the string is 2. Similarly, NW is 1 minus SE is 1 minus minimum value will be 1, and then you will have to plus 1. In this case also the option 2 value is 2. So if you do the same thing, you also will find that this option is 2 and this option is 2. Alright, and moving on, what we have is that we have to update the table. Update the table. Now the best value in the table become 2 for index 1. Then we move on and then we update the next value, which is W. So here we update it as well, right? And then what we do is that we again keep on doing the check all the 4 options available. So northeast will be 1, right? You have 1 and you have 0E should be 1. Minus SW. What is the SW? SW here you have 1 here and then you have 1 here. So you have 2 SW minus minimum, which is 2. Because 3 is the value of K and SW value now is 2. Plus 2. In this case you have 3. Alright. Now NW is 2. Minus SE. SE is 1 and 0 should be 1 here. Then it will be 1 here and then you're going to plus 1. You're going to have the value of 3. Alright. Similarly, if you follow the same step, you're going to have here 3 and also the option 3 is value as 3. So now at the index of 2, what you're getting is the value of your best value of Manhattan distance is 3. Now let's update the best value and then we move on to the next index in the string. So I update here 3. Now the next value that we're going to update is at index 3, which is W, so then I update the value of W to 2. Alright. Now if I continue the process now, NE is 1, correct? n is 1 and e is 0, minus sw. What is sw? Sw is a 3, minus what? K value is 3 and sw is 3 now. So 3 minus 3 will be 0, plus the minimum value of kw is 3, which is we get 4 here. Alright. So nw here is will be 3 minus se. So se is 1. So will be minus 1 plus 1. Here will be also 4. Right. If you do the same operation, you also get 4 here and 4 here. So in this case, in index 3, the best value that you can get when at a distance will be 4, based on the 4 option that you have, right? So now let's update this table now with 4. Now let's look at the next string. The next string is e, so I'm gonna update here e. That's one, right? So in this case, let's carry out the calculation. And e now is 2, right? And e is 2, right? N is 1, e is 1. So now you're going to minus sw. Sw is what? 3 here. And you're also going to minus 3 from here. And then you're going to plus 3 here. So 3 minus 3 is 0. And 2 plus 3 is 5. So this is for option 1. Option 2, nw. Nw is 3 minus se. Se is 2. So the best minimum is 3. Between 3 and 2 will be 2. Then you're going to add 2 here, right? This will be 5. Alright. If you do the same operation here, what you get is 5 here and also 5 here. So what we can see is that in the case where we move to the operation of the index 4, we actually have the value of 5. Alright. So let's update the table again that we have for the best value to 5, and then we move to the last character in the string, which is w. So w now become 3. Alright, right? Now let's do this operation again. Ne is 2, right? Sw is what? Sw is 4, right? S is 1 and 3 is here, right? What's the minimum value? So minimum value will be 3, right? Although your SW value is 4, but then your K value is 3. So you're limited by the value of K. Then you have to plus the value of 3. So in this case, for the option 1, when you carry out the changes, the maximum value or maximum Manhattan distance that you can achieve is 5. Now moving on, let's look at NW. NW is what? NW is 4 here, alright. Minus SE. What is SE? SE is only 2. So in this case, minimum value between K and SE is 2. And then you're going to add 2 here. So in this case, what you get is that 4 minus the difference between 2 and 2 is 0. So you still have 4. And then you're going to add 2 to here. Then you're going to get at 6. And then let's look at option at 3. You're going to have 2 here. SE is 2. 1s and 1e minus nw. Nw is 4, but then this is limited by 3, and then you're gonna add the 3. So in this case, what you're gonna end up is 5. So the last option is sw. Sw is here is 4 minus ne. Ne is 2. Now the minimum value is between 3 and 2. You look at 2. Then you're going to add the 2 here. So the best option is option 4. So between all these options, the best option is 6, right? Yeah, the best value is 6. So in this case, let's update our table to 6. And this is actually the answer. So this is how you solve the problem. By considering all the 4 options, and then from all the 4 options, you're trying to find what's the best value. And then you keep updating your best value at each point of your S string. So in terms of the cost of operation, if you do this operation, yes, you're doing each step, you're calculating 4 options, but then this is a linear operation. You're just moving on at each index of S. So the operation is actually it's a linear operation depending on the length of the string, and it will be a linear operation, or to the power of n. Now let's look at the code. The code is pretty simple. You have a dictionary for north, south, east and west. You initialize the dictionary, your best value will be 0, and at each iteration you are adding that particular string character to the dictionary, and also you are calculating the value of a northeast, northwest, southeast and southwest. So the northeast value, you are adding the value of the k and w value, and then you're minusing the opposite direction minus whatever changes that can occur. So then you are calculating the best value between all these cases, and then you update the best value, and then you solve the problem. So that's how you solve this problem. Thank you very much for listening.